So this opcode and data format, this will go to the instruction register, this will go to the data registers. In case that these cannot be distinguished, then first of all this comes in, like for example in 8085 this cannot be distinguished, so basically this comes in first and then goes into the instruction register. This come in next. So this will be taken through the instruction decoder, and whatever it is that this opcode signifies, that circuit will be on. Then the data 1 and the data 2. Okay, so this will be brought in using three different but consequent timing cycles. This is for 8085. In many other processor architectures, they may be brought in together. But in any case, the first one is identified as an opcode. The second one is, and depending upon the opcode, for example, if this is a shutdown or halt, then no data is required. So in that case, this will be another opcode. But if this is something like addition, then obviously we expect one data and another data. And this will all be timed so that the distinction will be made through by the timing cycle. The first timing tag, for example, take this one. So the computer will know the first timing cycle is output, second timing cycle is data, third timing cycle is also data, like that. Now it is easy to see that if the programmers try to use this format, they will be confused. Then obviously when you're doing some programming, what do? You actually write out these on a piece of paper and try to do it. But if you're writing these kind of programs, you can imagine it's very hard for a human being to program like this. It will be very confusing. What if a 1 0 or a 1 goes wrong? And if you had a big sequence, you won't be able to understand. See, already the sequence is a bit tough. I mean, whether there is a 1 in place or a 0 out of place, you cannot always check. That is how it is with human beings. So we need something better. And for that, we use something called assembly language, which is a mnemonic code. Rather than using, so what is the mnemonic code? So rather than using the instruction codes like this, we add instruction codes like add, subtract, etc., etc. What are the mnemonic codes? So these are mnemonics for all instruction codes. Then what exactly step by step as a machine instruction code? Okay, just like that. Except that, so it performs one atomic step at a time. So if you have x plus y plus z, you have to have x plus y. Then you have the result plus z, like that, atomic steps at a time. Okay. But and it is exactly like that, but except the fact that it is exactly like that, there is an advantage that it is in English like words. So basically English words. So that's why it's easy to write out and easy to debug and easy to use for human beings at least. Okay. So we perform one atomic step at a time, just like that. In case of assembly language also. In case of C, you don't do that. In C, you can bunch quite a few operations together. And it is up to the compiler to divide it and break it down so that the computer can perform one after the other, the proper steps. If there is any logical, if there is any logically, if there is anything wrong with your program, that is the stepping is wrong, then the program will also be wrong. In case of assembly language, you cannot bunch these steps together. You have to do them one after the other, just like in case of machine instruction. Difference is only that is in English-like format. And obviously the size of the instruction that is coming in depends upon the kind of instruction. For example, addition is a three. If one data is one length, then we have got a three length instruction for addition. Okay. Then if you are mentioning halt, which is like stop everything, then that's a one length instruction, like that. If the length that we're talking about is a byte, for example, in 8085 it's a byte, then addition is a 3 byte instruction. For example, um, if there are certain load and move operations that directly connect to a register and it takes one data, there is a 2 byte operation. and things like halt, etc., are just one byte operation. Now, how many different types of instructions can we have in a computer? And obviously, that exactly we'll have in the assembly language as well. Simple. If you have those many operations, then those will be there as well. So, how many types? So, memory related operations. Okay, memories and registers, basically those related operations. So, data moving, then copying. Okay, that can be from registers and main memory both, and it can also be between register and memory. So you can load data into registers and data into memory, as also that you also can interact between register and memory. It all happens through your command, mind you. You won't do it on its own. It will all happen through your command. Input output operations obviously there, and issuing interrupts or handling interrupts. What are interrupts? When you're doing some work and something more important has to be done. For example, if you're browsing and some antivirus software has to work on, then it issues something called interrupts. That is, it interrupts the work so that it can be serviced. So those interrupts can be handled. Branching instructions can be there. Branching instructions means the condition that, okay, so for example, sometimes you need to jump from your bit of code to another bit of code. Like for example, in C, you have used branches like this, that input n by the user, and if n is lesser than 10, do something. If n is between 10 and 100, do something else, and if n is greater than 100, you do something else. So there are three branches there. So these branching instructions can also be there, or are there rather. The branching instructions are there also. Then operations like DMA, etc., there are special operations like direct memory access and others that have to be done. And last but definitely not the least, the most important, for which we do the computations mostly, arithmetic and logic operations. Things like plus, minus, division, multiplication, modulo, also things like greater than, equal to, lesser than, and so on and so forth. All these arithmetic and logical sort of operations, these are obviously a must. These are the part of the ALU proper. So ALU, arithmetic logic unit. It is named after the arithmetic and logical operations that it must do. Primary operations here. Primary is the last one. So this is how the different types of operations are set unfold. And we'll see an example.